Hello everyone, my name is Rusty King and I'll be going over the ATP pathways that we discussed in class this week. As you're probably wondering, I mentioned ATP already. You might be wondering what that is. Well, it stands for adenosine triphosphate. It's a high phosphate and high energy phosphate chemical in the body that, when broken down to adenosine diphosphate and phosphate ion, releases energy that allows our body to do work. And it is sometimes described as the energy currency of the body. And what is meant by this is that ATP as a source of energy that the body uses to most to do any activity. At any given time, our bodies uh, have something equivalent, about the equivalent size of a stick of butter, which, if you think, is not that much. Um, so the body constantly has to uh, produce more ATP to to um, restore what it uses as we do uh, as we do work. This leads me to how ATP is produced. ATP is formed by the metabolism of sugars, fats, and proteins. During this presentation, I will be focusing in on the breakdown of glucose and fat or palmitates. Glucose is formed, is, uh, ATP is formed through glucose when it's broken down both anaerobically and aerobically. It is broken down anaerobically in the cytosol to allow the body to jumpstart the, um, the ATP production. It, when it's in the cytosol, it uh, is uh, is broken down using is broken down into pyruvate using oxidation and reduction. During this process, glucose comes in contact with NADH and acetyl CoA. After it encounters acetyl CoA, it enters the Krebs cycle or citric acid cycle, where it encounters more NADH and FADH2. When you put all these together, the breakdown of glucose produces 36 ATP per uh, uh, 30. It produces 36 molecules of ATP for each molecule of glucose. ATP is also formed from the breakdown of fat, or palmitate in this case. Fat is broken down uh, aerobically by the mitochondria, where it is oxidized. Once acetyl CoA comes in contact with the oxidized fat, the fat also enters the citric acid cycle. The products of the citric acid cycle are electrons and CO2. The oxidized fat, some of the oxidized fat also comes in, it produces electrons from the citric acid cycle. When these some of the oxidized fat come in contact with, and the electrons come in contact with NADH and FADH2, it enters a process that called the respiratory chain, uh, where it uh, where it creates. It also comes in contact with two hydrogen ions and uh, half an O2 molecule and ADP and a phosphate ion. The respiratory chain produces um, produces water as a product, and it also produces um, ATP during this process. Um, at the end of the breakdown of the the fat, it actually ends up producing quite a lot more than the glucose did. It produces 129 molecules of ATP for each molecule of fat. As I stated before, the breakdown of glucose only yields 36 ATP molecules for each molecule of glucose. And while the glucose is easier for the body to break down, it has its limitations, mainly in that it has such a small yield of ATP. On the other hand, the fat, uh, when it's uh, broken down, it yields 129 molecules of ATP for each molecule of fat. Um, but on the other hand, the fat has its limitations as well, in that it takes longer to break down than the glucose does. So um, that that's the limitations of glucose and fat. Um, you may be asking yourself, well, this is all interesting, but why is it important? Um, it has to do with our body's um, ability to do work, and the intensity and duration that it can do that work. You can see that as you if you try to do a lower intensity uh, activity, you're able to do more of an more and do that activity for longer. Whereas if you have high intensity, um, your body is not able, it fatigues faster, and um, it's like when you're doing like lifting weights, you're are able to do a lot more reps if you do like just do a 15-pound weight, where if you try to do a 50-pound weight, it's a lot harder to do as many reps as you could with a 15-pound weight. In conclusion, our bodies are sort of like cars, in that the small reserve of ATP that our bodies store inside them, that's almost like the battery of the car, where it gives the body what it needs to do work while it's at rest. Um, or when you break down the glucose, that is almost like the starter. It jump starts the activity, and that is sort of like the starter, and that it gets everything going. Um, where when you break down the gas, or the gas is almost like the breakdown of the fat, where it allows you to do the the the, the activity longer, um, and it sustains the ongoing processes of the body. Um, the body can't just rely on one form of ATP production. It has to use all of them because um, if you try to just rely on the glucose, it falls short because of the low yield. And if you try to rely on just on the fat breakdown to form ATP, you would run out of energy because it takes longer to produce the ATP that the body needs to continue. I'd just like to thank you for your time, and I hope you all have a great day. Thank you.